All right, this is the answer key for the Math6 test on expressions and equations. So you want your test in front of you, you want something to write with, you might even want your corrections sheet with you right now because you can fill that in as we go along. Remember, on the corrections sheet, everybody needs to complete that. The only ones that wouldn't would be students who earned 100% because they would have nothing to correct. So you are correcting your mistakes on that sheet. You're trying to understand what you did wrong, and then you're listening for what you should have done as well. So you can work on that as we're going along here, or you can just watch the video answer key and then do that corrections sheet when we're done. All right, let's keep going. In this first section here, you had to kind of know your expressions and your exponents, really. In this first one, they wanted to know if it was true or false. Now, the reminder I put down here is that exponents are repeated multiplication. So if you want 3 to the 9th power, then you want 3 multiplied 9 times. And that is a whole bunch of 3's that are all being multiplied. So you get a very large number, okay? And it's definitely not 27. All right, so that's false. If you thought it was 27, then my hunch is you just multiplied 3 times 9 and you got 27. But that's not what this is really representing. It's representing this right here, 3 9 times. In the second one, you had to know that squared means that your exponent is 2. So this is really 4 with an exponent of 2, 4 to the 2nd power, okay? And if you multiply that out, you get 16. So that one was good. That was true. In the third one, 2 to the 3rd power, well, that would be 2 multiplied 3 times, 2 times 2 times 2, and we get 8, which is what the problem said. So that is also true. In the fourth one, you had to remember, well, if squared means your exponent is 2, cubed meant that your exponent was 3. So I put that right there. So really we want 1/2 to the 3rd power. That would be 1/2 times 1/2 times 1/2. And just a reminder here, when multiplying fractions, you multiply your numerators and you multiply your denominators. So if I just write them all side by side by side, I would get 1 times 1 times 1, which is 1, and 2 times 2, that's 4, times another 2, that's 8. So 1/2 to the 3rd power is really 1/8. So over here, it's not 3/6. That was false. In the next learning targets section, oh, it's not there yet. There was one more problem. You had to come up with a power whose value was between 50 and 95. And then you had to prove that it was between 50 and 95. There are a few options here. I said answers may vary. All of these equal something that's between 50 and 95. 8 squared, 9 squared, 2 to the 6th power, 3 to the 4th power, 4 to the 3rd power. These all equal something between 50 and 95. So you had to write a power that worked. There was one little simple shortcut you could have done, though, because if you realize that any number to the power of 1 is going to equal itself, you could have picked any number between 50 and 95 and made it to the power of 1. That's another way of showing something that's between these. So that brings the first section to a close. The next section right here, learning target 22, you had to write an algebraic expression for each of these scenarios. You had to use variables, you had to use the correct operation, you had to use something that made sense of it. Well, remember that the variable usually represents what we don't know, okay? So look at this first problem. 3 more points than how many Katie scored. Well, what's unknown here is how many Katie scored. So let's use our variable for that. We want 3 more than X. You could have used any letter. A lot of kids used K. I just used X since it's the most common variable. But we want 3 more than X, essentially. And we write that just like it said it, 3 more than X. X plus 3. In number 7, 1 less than 2 times Jade's score. Well, again, ask yourself, what information do we not have? We don't have Jade's score. We don't know what her score was. So that's what we're going to use for our variable. We're going to represent that with X. And if you read it again, 1 less than 2 times X. Okay, 1 less than 2 times the value of the unknown. Okay. Now, This one's going to be a little tricky because you'd first need to know what 2 times Jade's score is. You first need that information right there. And then if we want 1 less than it, we have to take away 1. So this one had to be 2x minus 1. I saw a lot of people that had 1 minus 2x or 1 minus 2j. That's not the same thing as what it's saying over here. Because if we want 1 less, remember that flips it to the end of the problem. That becomes the minus 1. All right, if you want 1 less than 3, that's really 3 minus 1. If you want 1 less than 20, that's 20 minus 1. So whatever this is, minus 1. And number 8, Trey and 3 friends each go to the movie theater. They buy a ticket, a snack, and a soda. You want the expression for the total cost. Well, there was a couple things going on here. First, they each spent some money. Okay, so the ticket, the snack, and the soda. But we don't know that one's value, so we're going to use X. But we also have 4 people that were buying that. So you want that amount. If that's one person's total, really you want that quadrupled. You want that times 4. And number 9, you buy 3 pens for X dollars each using a $20 gift card. So we want the expression that shows this. Well, you have 20 bucks on your gift card. You're going to buy 3 pens that each cost X dollars. So this would look like this, 20 minus 3x. Again, x is the cost of a pen. 3x would be the cost of 3 pens then. And we want to take that away from the value of the gift card so we can see how much we have left. It's kind of how we usually think about gift cards. I've spent 20 bucks. Well, I had 25, so that's 25 minus 20. Or in this case, the cost of the pens taken away from 20. All right, turn your page. Number 10, this one, you had to come up with something equal to 12. And you had to use at least 4 different numbers and at least 2 different operations. Okay, again, operations are adding, subtracting, multiplying, dividing. So a whole bunch of options here. Okay, the only thing I was really looking for was, does it equal 12 when you follow the order of operations? Have you used 4 different numbers? And have you used 2 different operations? Like in this example right here, I've used 4 different numbers. I've used 2 different operations. I used subtraction and multiplication. So this problem meets the criteria. There's a whole bunch of options that work there. You guys came up with some very good answers for that one. In number 11, you had to plug in these values into these expressions and solve them. So like in this first one here, we want 4 times n when n equals 1, 2, 3, and 4. And this is what we end up getting. We end up getting those values that I have circled, and you can see the work right above it that shows us how we got there. 4, 8, 12, and 16, because this would be 4 times 1, this would be 4 times 2, 4 times 3, 4 times 4. Again, we're just substituting this value in for the variable, and we should remember that when they're next to each other like this, they want us to multiply 4 and n. This one was a little bit different. It was 4 to the power of n. So if we plug in an exponent of 1 or an exponent of 2, 3, and 4, well, now we're going to get a different result. 4 to the first power is 4. 4 to the second power, well, that's 4 times 4. It's 16. 4 to the third power would be 4 times 4 times 4, and we end up here. And then this is 4 to the fourth power, 256. So we get different outcomes with our values because we had different expressions. In the next section here, number 12, you had to figure out how many songs each person had on their music device. They gave you the value of n right here when n equals 50. So you plug in 50 for n each time, and then you worked it out. And you find out that really Jenna had a whole bunch of music. The rest had some music. Mary had the next highest amount, and so on. But in the problem, they wanted you to put in order from greatest to least, the order of who had the most music. So Jenna had the most at 200. Next up would have been Mary at 57, Chris at 48, and last was Gio at 25. In these bottom 4 problems, you had to plug in the values of the variables, and then you had to solve them. That's what evaluate means, solve the problem. So the first thing you should have done in each problem is to rewrite it with the values plugged in, okay? This is really 20 minus 4 times 2 plus 2 times 25 hundredths. All I've done so far is substitute these in for C, X, and Y. So I just wrote it out with the numbers in there now. And then I start solving it, and I follow my order of operations, and it leads me to my answer of 11 and 50 hundredths, or 11 and a half. Number 14, kind of the same approach. First thing you should do is substitute your numbers in there. And then you can see that this is really 5 times 20 plus 2 times 25 hundredths. And if you follow your order of operations, you want to multiply and you want to multiply. And then lastly, you want to add those. And you end up with 100.5. In 15 and 16, it was the same kind of thinking, but now you have new values for A, B, and C. So again, if we substitute first, that's what we're substituting in there, and then we start solving that, and we end up with an answer of 3. If these are going too quickly, pause it, slow it down, take your time, and then come back when you're ready. In number 16, you were to just again substitute, and then start solving your problem. Keep in mind the exponent was outside the parentheses, so you got to do the 3 times 2 first, and then you'll square it. All right, so you end up with that, and then if we solve that, we get 100 plus 36, which gives us 136 in the end, okay? All right, the next page here, this was a big chunk of your test. It was properties. You had to kind of apply the properties. Well, number 17, you had to find the associative property of addition. You had to prove that. What you want to remember with the associative property of addition is that you're really adding 3 things, but what changes when you're adding those 3 things is what you're associating or what you're grouping together. Like here, we grouped these 2 together, but in the second one, we grouped the last 2 together. But the bottom line is that it's okay with addition because you get the same answer. Okay, if I use these numbers, I would get 6 over here and I'd get 6 over there. This also would work for multiplication, okay? But they asked for the associative property of addition, and that's an example of it. In number 18, you should really have just worked these to see what happens, and you find out that you get different results. Okay, in this first one, you do this first and then times 4. But if there's no parentheses, well, now you need to start with the multiplication because that's more important than adding. So you'd get 12 plus 80. And we get different answers. So this one was false, and you had to explain why. In number 19, they wanted you to say if this was true or false and support your position. Well, remember that commutative means to change positions. Like when I commute to work, I'm changing my position from being at home to being at work. So what they want here is subtraction. If we change the position of the numbers, do we get the same answer? The answer is no, we don't, which makes this one false. And here's an example. 4 minus 3 is not going to equal 3 minus 4. So we've switched our numbers, but we get different answers. So this is not true. Okay, if it said addition of whole numbers is commutative, we're okay with that. That's true. Multiplication is commutative, but subtraction is not. Division also is not. So they could have said that. But that one was false. Number 20, Lauren says that this expression is equal to x squared plus 3y. Well, I summarized this right here. If you're adding, that would really be 2 x's. But if you're multiplying, that's y to the 3rd power. And that's not the same thing as what she has here. So she was incorrect, and you had to prove it or explain it or show it in some way. And number 21, the reminder I gave you before your test was make sure you distribute. And you also wanted to do it down here too. But you want to distribute first, because if you distribute first, then you can combine terms. So I distributed 5 times x and 5 times 3, and then I saw a new problem that I could combine. Okay, I can combine 2x and 5x and 4x, and I get, that would be 11x. but then I can also combine this 15 and the 2, and that's where the 17 came from. This is essentially 11x plus 17. That would be an equivalent expression for it. Number 22, you had to figure out, again, if these were equivalent to this one, or neither. So here are your three expressions, and a reminder, you should have distributed right here. You should have realized that that's really 8t plus 32. Because if you do that, you can see that that one is this right here. So that was quickly evident if you distribute it. You want to distribute here as well. 4 times 2t was 8t. 4 times 1 was 4. So this is 8t plus 4. Well, now I can see that that is the middle column. And then this one down here, if I look at my terms that can be combined, 1t and 1t and 6t, that's 8t. Then I have a 2 and a 2. Well, that's the plus 4. So I'm back to that middle column. So those three should have been middle, left, middle. All right, the last page here. Amani's hosting a movie night that she wants to raise money for a family member. Ticket sales were a little bit different for kids and for adults. They were a little bit cheaper for kids. In number 23, write an expression to show the total amount of ticket sales for A adults, S students. When they give you this right here, you should have used those in your expression because we know that adult tickets are $4.50 and we know that kid tickets are $3.50. So you could have written something like this, okay? The number of adult tickets times $4.50 and the number of kid tickets times $3.50. You want to add those amounts together, and that will tell you how much money they made. Now, we don't currently know how much money they made because they didn't tell us yet. That's why we're using variables, okay? But we wanted to show how we would figure it out. So $4.50 times the adult tickets plus $3.50 times the number of kid tickets that were sold. Number 24, her goal was to raise $750 for the family member. Later, she learned that this many students and this many adults showed up. Did she reach her goal? Well, this is where your equation or your expression really can help you because now we can plug in a number for the number of adults. And a lot of people did this. And they can also do the same thing with the number of kid tickets. So now we know it's really 450 times 120 plus 350 times 80. Okay, now we can work with our expression. And if we do that, we find out that that's a grand total of $780. Yes, she reached her goal. She reached it by more than $30, by $30 exactly. Now they want some snacks and drink prices. So you can see here, number 25, Paulo orders 2 popcorns, 2 pieces of fruit, 2 drinks for himself and a friend. Write 2 expressions that can be used to find the total cost. Well, we don't have numbers here, so we had to use the variables. And again, answers can vary, but here was a couple options here. A lot of people did something like this. If they did 2 popcorns, 2 fruits, and 2 drinks, you would really just add all these together if you knew their numbers. So that was one good expression that you could have come up with. Some people did this, they said, okay, well, it's, 2 of these and 2 of these and 2 of those, and I want to add those amounts to get the total of what the snacks cost. So you could have done that as well. These are equivalent. There was another one that some people came up with, and this was good thinking as well. You could add up what 1 popcorn cost, 1 fruit, and 1 drink cost, and then double it, or times it by 2 in some way. That was another thing you could have come up with for that. All right, that brings your test to a close. Here is what you need to do now, all right? You should have this corrections sheet. If you don't, get it from me right now. But you need to make sure you do this, okay? This is going to be a grade that goes into Infinite Campus as well. You want to show me that you've learned and understand your mistakes, all right? So you should have this sheet. We've done this before. It's required for every student. And I will remind you that you need to do this for the problems you missed, all right? Not just some of them, not just one of them, but all of the ones that you missed. So if you missed 6 problems, then you're doing this for those 6 problems. There's more space on the back of the sheet if you need more. But you want to learn from your mistakes. Remember, math is a subject that builds and build. And to not know it now makes things more difficult later when it comes back, all right? So this is required. This is your assignment. This is what you should begin working on now.